Welcome to Mr. eScienceTheater presents Empirical Formula and Molecular Formula. The empirical formula is defined as the smallest whole number ratio of atoms in a compound. The molecular formula is actually just the actual formula of a particular compound. So the empirical formula is the smallest whole number ratio of atoms in a compound. So for example, if I look at the compound C2H6, this is a molecular formula because that's the molecule, C2H6, but the empirical formula, both of these, 2 and 6, have a common factor of 2. So if I factor out all the common factors, think of it like reducing a fraction to the lowest terms. I factor out a 2 and I get CH3. So whereas this is the molecular formula, this is the empirical formula. Okay, so again, C2H6, basically this is saying that there are 2 carbon atoms for every 6 hydrogen atoms in this molecule. Well, 2 to 6, that ratio 2 to 6 is a fraction that can be reduced to 1 to 3. So 1 to 3. This is the empirical formula, the smallest whole number ratio. So that's what it means to have the empirical formula. So empirical formula is a ratio of atoms in a compound by moles. It's the number of moles. Whereas percent composition, that we learned about previously, was the ratio of the elements in a formula by mass. So to convert from one to the other, we can use the grams to moles conversion, which we call the molar mass. So finding the empirical formula, there are some basic steps. So in finding the empirical formula, basically first thing we do is we find the percent composition of each element. Then we find the moles of each element. Yeah, we'll pretend that says element. Then, this is the fun part, we divide the moles of each element by the smallest number. And I'll show you in a second in an example what this looks like. And then, if necessary, we're going to multiply by a number, 2, 3, 4, whatever, to get whole numbers. And again, I'll show you what this means here in just a second. Okay, so those are the basic steps. Find the percent composition of each element, find the moles of each element, divide the moles of each element by the smallest number of those moles that you found in step 2, and then if needed, multiply by 2, 3, or 4. And let's work out an example here. So here, for example, we want to find, and I'm just going to call it EF for empirical formula. Find the empirical formula for a sample that is 25.9% nitrogen and 74.1% oxygen. So, according to the steps, first thing I want to do is find the percent composition of each element. Oh, look at that. I've got the percent composition of each element. I'm good to go. Step number 2 is to find the moles of each element. So I need to convert these percents into moles. Now, percent to mole isn't really a thing. So what I'm going to do is, because it's just a sample and a percentage, I don't have the sample size. I'm going to pick a convenient sample size. I'm going to say, well, what if I have a sample size that's 100 grams? Well, that means it's 25.9 grams of nitrogen and 74.1 grams of oxygen, because that's the percentages. So if I'm given percentages, to convert them to moles for finding empirical formula, I'm simply going to just replace the percentages with grams, because I'm just going to pretend I have a 100-gram sample. So I'm going to start with a 25.9 grams of nitrogen. And to convert to moles, I'm going to put grams are on top here. I'm going to put grams of nitrogen on the bottom and moles of nitrogen on the top. And then the number that converts grams to moles is the molar mass. So I go to nitrogen, it's 14.01 grams for every 1 mole, like so. The grams of nitrogen will cancel, leaving me moles of nitrogen. So 25.9 divided by 14.01, I end up with 1.85 moles of nitrogen. I'm going to do the same thing with the oxygen. 74.1 grams of oxygen. Get rid of grams of oxygen, I'm going to put on the bottom. Get to moles of oxygen, I put on the top. Again, molar mass of oxygen is 16. Get that from my periodic table. That's 16.00 grams of oxygen for every 1 mole. Grams of oxygen will cancel. 74.1 divided by 16.00 is 4.63 moles of oxygen. So there we are. So I have done step number 1 where I have the percent composition. I have found the moles of each element. Now I need to divide the moles by the smallest number. So I have 1.85 and 4.63. I want to figure out which one is the smallest. Well, 1.85 is clearly, so I'm going to divide both sides by 1.85. 1.85 divided by 1.85, like so. And that, of course, is 1. And this number turns out to be about 2.5. What this means is that for every 1 nitrogen, I have 2.5 oxygens. So my formula would simply be N1O 2.5. But you can't have 2.5, and so this is where that last step says, if needed, multiply by 2, 3, or 4 to get whole numbers. So in this case, if I multiply everything by 2, I'm going to get whole numbers. In other words, N2O5. That's my empirical formula for a sample that is 25.9% nitrogen and 74.1% oxygen. So again, just following those steps, we found the percent composition. It was actually given to us that way. We found the moles of each element by converting using molar mass. 1.85 moles of nitrogen, 4.63 moles of oxygen. Step 3 was to divide the moles by the smallest number. 1.85 was the smallest number of moles, so I divide all of these numbers by 1.85. This gives me 1 nitrogen and 2.5 oxygens. So my formula is N1O 2.5, except you can't have a partial atom. So I'm going to multiply that by 2 so that I get whole number subscripts on my chemical formula, N2O5. And that is how we find the empirical formula, following those steps. So suppose I want to find the molecular formula. Okay, so the molecular formula, remember, is the true formula, the actual number of atoms, not just the smallest whole number ratio. So finding the molecular formula, I'm going to just call that MF for molecular formula. So step number 1 is to find the empirical formula. Okay, then step 2 is to find the empirical formula mass. And then step 3 is to divide molecular formula mass over empirical formula mass. That's going to give us a number. I'm just going to call it N for now. And step 4 is to multiply the subscripts of the empirical formula by N. In other words, take the empirical formula and multiply every subscript by N. That will give you then the molecular formula. So let's do an example of this. So suppose I have some compound, I'm going to call it compound X, and it has an empirical formula of CH2. And I want to find the molecular formula if the molecular formula mass is 42.10 grams per mole. Okay? So let's follow our steps. Number 1 is to find the empirical formula. Look, there it is. It's CH2. Step number 2 says find the empirical formula mass. Okay, well, empirical formula mass. So step 1 is CH2. That's my empirical formula. Step 2 is to find the empirical formula mass. That is carbon, which is 12.01, plus 1.01 times 2 hydrogens, and I get for that 14.03. That's grams per mole. That's my empirical formula mass. Step number 3 is to divide molecular formula mass by empirical formula mass. In other words, molecular formula mass divided by empirical formula mass And I do that, and I get 3. And step 4 is to multiply the subscripts of the empirical formula by n. In other words, I'm going to take CH2 and multiply each of those subscripts by 3. So I have C3H6. That is my molecular formula. And that is how you find molecular formula.